Advent of Code 2022, Day 10. Let's dig in. Day 10, Cathode-Ray tube. You avoid the ropes, plunge into the river, and swim to shore. Oh, okay. So I guess we were calculating the ropes positions yesterday to avoid them rather than to catch them and climb back up to the bridge. The elves yell something about meeting back up with them upriver, but the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritize getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining from a big crack in its screen tells you it probably won't be of much immediate use. Unless, that is, you can design a replacement for the device's video system, which of course we can, right? It seems to be some kind of cathode ray tube screen and a simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. Start by figuring out the signal being sent by the CPU. The CPU has a single register, X, which starts at the value 1. It supports only 2 instructions. Add V takes 2 cycles to complete. After 2 cycles, the X register is increased by value V, and V can be negative. No-op takes 1 cycle to complete. It has no other effect. The CPU uses these instructions in a program. Your puzzle input. All right, let's get our puzzle input. Get input 2022, day 10. Okay. 141 lines. Okay, so it's kind of short. Consider the following small program. X is 1 after the first cycle, no op instruction of execution doing nothing. Start the second cycle, add X. 3 instruction begins execution. During the second cycle, X is still 1. During the third cycle, X is still 1. After the third cycle, the add X instruction finishes execution, setting X to 4. Okay. I think I understand what's going on here. Maybe you can learn something by looking at the value of the X register throughout execution. For now, consider the signal strength, cycle number multiplied by the value of the X register during the 20th cycle and every 40 cycles after that. Okay. 20th, 60th, 100th, wait, okay, and 220th. I guess that's all we get, right? There's only 141 instructions, so it's not going to be very long. For example, consider this larger program. That is a larger program. The interesting signal strengths can be determined as follows. And then we have, so we're multiplying the cycle number by the X register to determine the signal strength. The sum of these signal strengths is 13,140. Find the signal strength during these, and what is the sum of these 6 signal strengths? Okay. So what we can do is we can use this as test input, right? Because we know the answer to that one is 13,140. There we go. And now we're going to just create a new module, or new file rather. Day 10, day 10, day 10, day 10. And then we create the file. 22, day 10. Oops. Day 10. There we go. So now we should get unsolved. Any second now. There we go. All right, this doesn't seem too bad. In our parse function, we can just read the lines. Let lines equals AOC lib read lines. We're going to just do the test input right now. And then we're going to parse them, right? But I'm trying to think of, should we create a little instruction thing, struct or enum instruction? Print them out, and it's just add X amount. Let's just use I32s and then no op. That's it. That's the entire thing. And somehow we're going to have to remember that add X takes 2 cycles. All right, we'll figure that part out when we come to it. A 4-line inlines let words equals line dot split on space dot collect vector. So real quick here, and then match words of 0. If it is no op, then we just do instruction no op. Here we'll just do the statements, just effective instructions. So this will just be self statement push, whatever we do here. So that's a no op, and then we have add x, and those are the only two we can deal with right now. So this will be instruction add x words 1 dot parse dot auto. Right, can we fit that on one line? And then nothing is panic. Unknown monic of word 0. There we go. And that should, oops, that should parse everything. What did I mess up? Oh, I have to close the push first, and then a semicolon, and then close that brace. Cargo check. It worked. We can just do a quick print just to see what's going on here. Self statement. Let's see if it looks close to these longer program instructions here. Add 15, add -11, add 6. Let's see if there's a no op in there. Add 4, there's the no op. Okay, so I think everything's working. That looks pretty good to me. Now we just have to execute it. So part 1 is going to be this here. So we're going to start at, I guess, what are we doing? Signal strengths. So let's create a variable called signal strength. Or just strength. Starting at 0, because it's a sum. And then we'll execute each instruction or statement. We'll say S in statement, match S. If it is a no op, we do need to, okay, we need to keep track of a few things, right? We need to keep track of our current X register. They start at 1, right? Is that what I remember? Starts at the value 1. Yep. Okay. We also have to keep track of what cycle we're on, which starts at 0, I assume. It doesn't say. Yeah. I mean, it says during the 20th cycle is what we're doing it. So we start at 0, yep. And then let's keep track of which cycle we're going to check. And we're going to start by checking on cycle 20, and then we'll just add 40 to that each time. So here we need to do something. What do we need to do? If we're on the 20th cycle, then we have to add. So we're going to have a little bit of code duplication here, right? Because we need to do this for the add X instruction instead. But let's write it out with the code duplication, and then we can refactor. In fact, this might just be better inside its own little struct and impl. But let's see. So the first thing we'll do is say if our current cycle, do we add first? Yeah. So we'll say cycles plus cycle plus equals 1. If the cycle is greater than or equal to check, then what we're going to do is add the strength plus equals cycle times our current X register. And then we'll set the next check to be plus equals 40. And we need to do that for each one. Let's print that out too. At cycle, so we can compare it with the stuff that's over here. Cycle check signal is equal to this, and it's just cycle times X reg. So we'll see those. The next instruction is instruction add x with a value. And it says that during the instruction, while we're executing the instruction, the X register doesn't change. It's at the end when we set update the value of the X register. So xreg plus equals a val. While we're executing, we do this, right? So we can just do this, boom. Oh, we don't want this. We don't want the cycle. We want the check value here, right? Okay, so what made me think of that was that I'm adding 2 here to the cycle rather than adding 1. And we want to make sure that we are doing our check, or we're multiplying our check correctly. And then the result for part 1 is going to be just whatever our strength is. Right? Let's see what happens now. Are we getting, oops, we're getting nothing. Oh, because I messed something up here. I forgot to close the match. There we go. And that blew everything up. Oh, and I forgot the arrow. Okay, so these numbers look right? Yeah, we even get down to the 13,140. So that's not too bad. Let's change to our real input. And we get a 14,540. And that's the right answer. Okay, so let's take out these print statements. We don't need these print statements anymore. And I think that's all we need to do. A lot of the times with these puzzles is part 1 is can you parse the input, and then part 2 is a little more complicated. So git status, git add source, git commit -m 2022 day 10 part 1. There we go. Shania, thank you for the for showing up. Sorry, thank you for being here. What am I doing? Git status. Yeah, so we just need to do part 2 now. All right, what's part 2? It seems like the X register controls the horizontal position of a sprite. Ooh, this looks like a long one, huh? Ugh. Okay. Seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of that sprite. In this system, there is no such thing as a vertical position. If the sprite's horizontal position puts its pixels where the CRT is currently drawing, then those pixels will be drawn. Okay, you count the pixels on the CRT, 40 wide and 6 high. This CRT screen draws the top row of pixels left to right, then the row below that, and so on. Okay, so the vertical position is basically time-based, right? And I'm looking here, I can see, yeah, so cycles 1 to 40 is the first line, cycles 41 to 80 is the second line. Okay, that makes sense to me. So by carefully timing the CPU instruction, what is this? Racing the beam. Oh yeah, this is about the Atari 2600. You had to do something very similar. You had to time, you had a single line buffer, and you had to fill it before the CPU was ready to draw that line. And then you had to, between times, calculate the next line to put in that buffer. I don't know what this one is. While you're at it, go watch Everything Else by Retro Game Mechanics Explained Too. Okay. Not right now. By carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel. Otherwise, it leaves the pixel dark. Okay. I think I understand what's going on. We just have to look at we have to look at the current cycle and see if the current cycle matches where the X register is. And if it is, then we draw a hashtag, otherwise we draw a dot. I think that's all we need to do, but we need to, okay, this is part 1. Basically duplicate all this code. That's annoying. We could calculate it in part 1 like we did previously and then just print it in part 2. That might be the easiest thing. The other thing is we have to split this up into 2 cycle increments. So we can have a CRT, which is going to be a vec of string, and we can build each line one at a time. And then as we finish each line, we can just push it onto the CRT, and then this will just print out self CRT. Right? That should compile and print nothing. Oops. Oh, we can just return it. You don't have to output it. Oh. Clone? There we go. Okay, this is panicking because our print routine assumes that there's going to be at least one string to print, and there isn't. So let's fix that. Let's change this to be 1 cycle at a time. We still only need to check the check cycle at the end because we're not going to increment the X register until the end. But now we need we need to do this. We need to say if cycle is less than xreg minus 1, or cycle is greater than xreg plus 1, then we'll have a scan line. And we'll push the scan line onto the, or push the pixel onto the scan line. Scan line dot push tag. Else scan line dot push dot. And now we have to repeat this, right? Like that. There's probably a cleaner way to do it, but this seems to do the trick, or this looks like it would do the trick anyway. And then if our cycle, oh, we have to do it each time. That's annoying. If the cycle is, and we want to check it, oh, we want to increment after, I think. How do we want to do this? Okay, we want to check first and then increment after. So if cycle mod 40, oh, which is going to be true for the first one. We want to ignore it, first one, and scan line is not empty. Then we'll say self CRT push scan line, and then scan line equals toString. We just reset it. And now we have to do this each time as well. So we put that there, and then do that here. Right? That way we check to see if we finished a line. If we have finished a line, then we push it and we start a new line. And then check the X register and then increment the cycle and do it again. So this has to be all refactored, but at least we can see if we got something. Oops. Oh, cycle 1 equals 0. Duh. I think that's all we need. Oops, that didn't work. Oh, let's switch back to our test input so we can compare. Do they have the... They do. So this is what it should look like. Okay. 1G. There we go. All right. So it looks like there's a little bug. Oh, we got the first line right. Okay. So we just need to deal with... Oh, this is cycle mod 40. So each one of these has to change now. So this is why you don't... This is why you don't... you don't duplicate code because you got to fix it everywhere. I think that's it. No, it's not. It looks like I have this line backward. Oh, I have all of them backwards. I have all, yeah, and then, so now we have to switch all these. I'm going to refactor this as soon as I solve the problem because this is bad. All right, so as long as it's the right way around. It looks like we're cutting. I see only, yeah, it looks like we're cutting off the last line. Of course we are. Self CRT push scan line. Semicolon. There we go. Okay, that looks better. All right, so let's use our real input. Oh, what are we even looking for? What 8th capital letters? Okay, yeah, so this is one of those problems. It should be some letters. Ta-da! Okay. Let's see if we got it right. I should write some code to translate these into actual letters, but E, H, Z, F, Z, H, C, Z. Submit. There we go. That's the right answer. Very good. Okay. What can we do to refactor this? If we make a machine to do this instead, how will that help? Struct machine, which has all of this stuff in here. The X register, cycle, the current cycle it's on. The machine doesn't care about this part, but we do have a scan line, right? So maybe a scan line. Impl machine. No, we want a new function because we need to set xreg to 1. And that way, what we can do is just call each instruction, which will do the work, right? So we can say fn no-op mod self, which calls fn cycle mod self, and then the cycle will do all of this work. Oops. Like that, and fn no-op just calls cycle, and then fn add x not self delta I32 calls cycle, and then xreg self xreg plus equals delta. The only thing is when this finishes here, how do we get that out? I guess the CRT can just be on here as well. CRT is a vec string. Like that. And then, so here we just say self CRT push, right? And then at the end, this will still do this, and this will just, let's get rid of scanline. Oh, we do need to check if the cycle is, so we do need to at least look at the cycle. So we'll just say machine like that, and we can just say machine cycle there. And then add x will be these same these same lines here, but then we'll do machine. Do we do this before or after we we handle the no op. Let's try it after and see if we come up with the same numbers. That's the best way to do it. Machine no op. Right? And then we do this machine.add x val. And then all this can go away. The only other thing here is this, there's no CRT on this anymore, but we do need to add that last scan line. How do we do that? I guess we could just do a single no op. That's kind of cheating, but it should work. Machine no op. That way it'll grab the next line. Maybe. Oh, and then the machine has to be here, which means we need a default. We do need a default for it. Dang it. But that simplifies this. A little bit. So if we put the machine in here, then it's self machine, self, 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 self. And then, oops, here we just say self machine CRT clone. And let's see what blows up. Oh, right, self cycle. Let's try it this way. And all the X regs have to change as well. We don't need that or that. X reg. I should actually make that a function, right? So it doesn't reach into the... Oh, okay. If scan line. Oh. Yep. And this is val here. Why can't we do this? Oh, because now it's that. Okay. One more. Oh. Does the string have empty? Oops, I missed a semi. No, there's an is empty, but clear. Yeah. And of course now it's all messed up. So much for the refactor. Is it because I did this backwards? No. Maybe. Nope, that's not that. Well, that's a shame. I really broke it. I should have committed the changes before I refactored it. Let's go to the test input and then we can see, because the test input has better pattern. It might be easier to see what went wrong. Yeah, so I must be doing it just at the wrong time, because here, right, that should be on, and then these got shifted over. Okay. And the values are wrong. Let's print out the values as we calculate them. And then we can also see those, because that might give us a clue as to why 399. Should be 420. So I'm doing it on the wrong cycle, right? So this here, maybe, and this here. just like we had before, but that wasn't changing anything. Yeah, it's still 399. So the no-op is basically we want to check the scan line first, right? That's what we do. And see if we need to push it. And if it's here, if it's in this range, we'll push that or push that. And then increment the cycle. That looks all correct. Yeah, I'm just missing. Oh, right. That was the problem. That's the problem. We want to say check times self machine reg. Okay, oops. So that should fix this. But it doesn't fix the scan line problem. No, that didn't fix that. Oh. No, yeah, that's right. We multiply it by the machine's X register. Maybe we want it as 380 and it was supposed to be 420. So if we do it that way. No. No. No, it's still off. Scooby Jesus says, what's the initial value of the X register? It should be 1. So when we create it, it's 1. Oh, that's right. You're absolutely right, because I'm doing a default on it instead of creating it, which I need to do. Self machine equals machine new. There. That was it. Thank you. Thank you for the help. Okay. So now if we can no, this is still wrong. 11,680. It's supposed to be 13,140, but we're closer, right? It's 420. So I think now I'm thinking we do this, but maybe not. Nope, that doesn't make a difference. Cycles plus 1, right? We have cycle plus 1 here, and we increment the cycle each time. And then if the cycles is greater than the check cycle, oh, is this backwards? No. Yeah, if machine cycle is greater than or equal to check, then we're going to add it in. And we're adding 400, and it should be 420. Let me see what the values are. Check self machine xreg. So we're doing it on the wrong cycle. 20 times 20. Yeah, so x machine or machine xreg is off by 1 still, even though I set this to new. This is correct, right? This looks all perfect. It's just that now the strength is wrong. It should be 60 times 19, and it's 16. 100 times 18 is correct. 140 times 22. Jukara says, what's your playlist? I have Pretzel set up for Christmas because I'm doing Advent of Code. I'm going to switch back to a lo-fi kind of thing after the Advent of Code is over. So it's just some goofy Christmas code music. All right. We're really close. It's just wrong. During the 20th cycle, X register has the value of 21, and I'm seeing 20 instead of 21. Jukura says it's advent of code time again. Holy, time flies so fast. Yeah, well, it's every December, right? So, and it has been. I think this is the 8th year now that Advent of Code's been going on. Yeah, it started in 2015. So, 8 years of Advent of Code. So it's clear that we have the wrong value in the X register, but here, when we actually do the work, it's correct. And where we do the work, we're calling add X to change the value. We call self cycle twice. Oh, and then we're modifying xreg. Oh. So, yeah, so this is coming in with the old value of xreg. But then the cycles have to happen, and then we have to check the old value of xreg. So maybe we do this. We say let previous x is equal to machine.xreg. Like that. Will that do the trick? Nope, because I messed up. Oh, this guy. This doesn't change the X register, so he can stay. He can stay alone. There we go. 13140 for the test input. That still all looks correct. And now all we need to do is switch this back to the real input. 2022 10. 14540. Yep. Okay. Thank goodness. There we go. That took longer to refactor than I wanted it to, but now it's refactored down into this. That's pretty good. The only thing that's bothering me now is that part 1 is doing all the work. And it should really be split out into part 1 and part 2, but it goes so fast. It's fine. Cathode-Ray Monk says that's much better. Thank you. The only thing that's bugging me, the only thing left that's bugging me is this. But I'm going to live with it for now. And the fact that we create a default machine and then maybe what we can do is just say machine init. I like that idea better. That way we don't need this new, but we do need an init. Which just says self xreg equals 1. Self cycle equals 0. Self scan line equals to string. And self CRT clear. There. And I left that there by accident. And this doesn't have a mutable self. And now we're good. Same values, same values. Very good. I don't know if that's better or worse. It feels worse now that I've done it. All right. Git commit -am 2022 day 10 part done.